The paradox of unconscious awareness. The concept of unconscious awareness presents a fascinating paradox that challenges our traditional understanding of consciousness and cognition. At its core, the paradox lies in the idea that we can be aware of something without being consciously aware of it. This seemingly contradictory notion has profound implications for how we perceive the mind, decision-making, and even our sense of self. To explore this paradox, we must delve into the nature of consciousness, the mechanisms of the unconscious mind, and the ways in which these two realms interact. The nature of consciousness. Consciousness is often described as the state of being aware of and able to think about oneself, one's surroundings, and one's experiences. It is the subjective experience of the mind, the inner world, that each of us inhabits. However, defining consciousness has proven to be one of the most challenging tasks in philosophy, psychology, and neuroscience. While we can describe its features, such as self-awareness, intentionality, and the ability to reflect on our thoughts, consciousness remains elusive when we attempt to pin it down to a specific mechanism or process. One of the key challenges in understanding consciousness is its subjective nature. Each person's conscious experience is unique, and there is no direct way to access or measure another individual's inner world. This subjectivity makes it difficult to study consciousness scientifically, as it resists the objective methods that are typically used in empirical research. Despite these challenges, scientists and philosophers have made significant strides in exploring the boundaries of consciousness and its relationship with the unconscious mind. The unconscious mind. The unconscious mind, on the other hand, operates outside of our conscious awareness. It encompasses a vast array of mental processes that influence our thoughts, feelings, and behaviors without our explicit knowledge. These processes include automatic functions like breathing and heartbeat, as well as more complex activities such as memory retrieval, pattern recognition, and emotional responses. The unconscious mind is often described as a reservoir of thoughts, memories, and desires that are not immediately accessible to conscious thought, but nevertheless shape our experiences and actions. The concept of the unconscious mind has a long history, dating back to the work of early psychologists such as Sigmund Freud and Carl Jung. Freud, in particular, emphasized the role of the unconscious in shaping human behavior, suggesting that many of our actions are driven by repressed desires and unresolved conflicts. While Freud's theories have been criticized and revised over the years, the basic idea that much of our mental activity occurs outside of conscious awareness remains a central tenet of modern psychology. The paradox of unconscious awareness. The paradox of unconscious awareness arises when we consider the possibility that we can be aware of something without being consciously aware of it. This idea challenges the traditional view that awareness is synonymous with consciousness. If awareness can exist independently of consciousness, then our understanding of the mind must account for this phenomenon. One way to approach this paradox is to consider the role of implicit knowledge. Implicit knowledge refers to information that we have learned and stored in our memory, but cannot easily articulate or access consciously. For example, we may know how to ride a bicycle or recognize a familiar face without being able to explain exactly how we do so. This type of knowledge operates at an unconscious level, guiding our actions and decisions without requiring conscious thought. Another example of unconscious awareness can be found in the phenomenon of subliminal perception. Subliminal perception occurs when we are exposed to stimuli that are below the threshold of conscious awareness, but still influence our behavior or attitudes. For instance, a brief flash of an image or a word that is too quick to be consciously perceived may still affect our mood or decision-making. This suggests that our minds are capable of processing information and generating responses without our conscious involvement. The role of attention. Attention plays a crucial role in the paradox of unconscious awareness. Attention is the process by which we focus our mental resources on specific stimuli or tasks, allowing us to process information more deeply and effectively. However, attention is a limited resource, and we cannot attend to everything in our environment at once. As a result, much of the information that we encounter is processed unconsciously, without our explicit awareness. This raises the question of how much of our mental activity occurs outside of our conscious attention. Research in cognitive psychology has shown that even when we are not consciously attending to a stimulus, our brains are still processing it at some level. For example, studies using techniques such as functional magnetic resonance imaging, fMRI, have demonstrated that the brain responds to stimuli even when participants are not aware of them. This suggests that our unconscious mind is constantly at work, filtering and interpreting information before it reaches our conscious awareness. The influence of unconscious processes on decision-making. The paradox of unconscious awareness has significant implications for our understanding of decision-making. Traditional models of decision-making assume that we make choices based on conscious deliberation and rational analysis. However, research has shown that many of our decisions are influenced by unconscious processes that operate outside of our awareness. One example of this is the role of emotions in decision-making. Emotions are often thought of as conscious experiences, but they can also arise from unconscious processes. For instance, we may feel a sense of unease or attraction toward a particular option without being able to articulate why. These emotional responses can guide our decisions in ways that we are not fully aware of, leading us to choose one option over another based on unconscious preferences or biases. Another example is the influence of priming on decision-making. Priming occurs when exposure to a stimulus influences our response to a subsequent stimulus, even if we are not consciously aware of the connection. For example, if we are exposed to words related to aging, we may subsequently walk more slowly, even though we are not consciously thinking about aging. This suggests that our decisions and behaviors can be shaped by unconscious cues that we are not aware of. The self and unconscious awareness. The paradox of unconscious awareness also has implications for our sense of self. The self is often thought of as a conscious entity, the I that experiences thoughts, feelings, and perceptions. However, if much of our mental activity occurs outside of conscious awareness, then the self may be more complex and multifaceted than we typically assume. One way to think about this is to consider the role of the unconscious in shaping our identity. Our sense of self is influenced by a wide range of factors, including our memories, beliefs, and experiences. Many of these factors operate at an unconscious level, shaping our self-concept without our explicit awareness. For example, we may have unconscious beliefs about our abilities or worth that influence our behavior and self-esteem, even though we are not consciously aware of these beliefs. This raises the question of how much control we have over our sense of self. If our identity is shaped by unconscious processes, then our ability to consciously direct our thoughts and actions may be more limited than we think. This challenges the idea of the self as a unified, autonomous entity and suggests that our sense of self may be more fluid and dynamic than we typically assume. The neuroscience of unconscious awareness. Advances in neuroscience have provided new insights into the paradox of unconscious awareness. Research using techniques such as fMRI and electroencephalography (EEG) has shown that the brain is capable of processing information and generating responses without conscious awareness. For example, studies have demonstrated that the brain can detect and respond to stimuli even when participants are not consciously aware of them. One area of research that has shed light on unconscious awareness is the study of blind sight. Blind sight is a condition in which individuals with damage to the visual cortex are unable to consciously see objects in certain parts of their visual field, but can still respond to them. For example, a person with blind sight may be able to accurately guess the location or movement of an object, even though they report not seeing it. This suggests that the brain is capable of processing visual information and generating responses without conscious awareness. Another area of research that has contributed to our understanding of unconscious awareness is the study of implicit memory. Implicit memory refers to the influence of past experiences on current behavior, even when we are not consciously aware of those experiences. For example, we may have implicit memories of how to perform a task, such as typing on a keyboard, even if we cannot consciously recall learning the skill. This suggests that the brain is capable of storing and retrieving information without conscious awareness. The philosophical implications of unconscious awareness. The paradox of unconscious awareness also has important philosophical implications. It challenges traditional notions of free will and autonomy, suggesting that much of our behavior is influenced by unconscious processes that we are not aware of. This raises questions about the extent to which we can be held responsible for our actions if they are driven by forces outside of our conscious control. One way to approach this issue is to consider the role of unconscious processes in shaping our intentions. Intentions are often thought of as conscious decisions to act in a certain way, but they may also be influenced by unconscious factors. For example, we may have unconscious biases or desires that influence our intentions without our explicit awareness. This suggests that our sense of agency, the feeling that we are in control of our actions, may be more complex than we typically assume. Another philosophical implication of unconscious awareness is the challenge it poses to the idea of a unified self. If much of our mental activity occurs outside of conscious awareness, then the self may be more fragmented and decentralized than we typically assume. This challenges the idea of the self as a coherent, autonomous entity and suggests that our sense of identity may be more fluid and dynamic than we think. The practical implications of unconscious awareness. The paradox of unconscious awareness also has practical implications for everyday life. Understanding the role of unconscious processes in shaping our thoughts, feelings, and behaviors can help us make more informed decisions and improve our well-being. For example, becoming aware of our unconscious biases can help us make more objective decisions and reduce the influence of prejudice and discrimination. One area where this understanding can be applied is in the field of education. By recognizing the role of unconscious processes in learning, educators can develop strategies to enhance learning and memory. For example, techniques such as spaced repetition and retrieval practice can help reinforce learning by engaging both conscious and unconscious processes. Another area where the understanding of unconscious awareness can be applied is in the field of mental health. Many mental health conditions, such as anxiety and depression, are influenced by unconscious processes that operate outside of our awareness. By becoming aware of these processes, individuals can develop strategies to manage their symptoms and improve their well-being. For example, mindfulness-based therapies can help individuals become more aware of their thoughts and feelings, allowing them to respond to them in a more constructive way. Conclusion. The paradox of unconscious awareness challenges our traditional understanding of consciousness and cognition. It suggests that much of our mental activity occurs outside of our conscious awareness, influencing our thoughts, feelings, and behaviors in ways that we are not fully aware of. This has profound implications for our understanding of the mind, decision-making, and the self. By exploring the nature of consciousness, the mechanisms of the unconscious mind, and the ways in which these two realms interact, we can gain a deeper understanding of the paradox of unconscious awareness. This understanding can help us make more informed decisions, improve our well-being, and develop a more nuanced understanding of the self. Ultimately, the paradox of unconscious awareness invites us to reconsider our assumptions about the mind and to explore the complex and dynamic nature of human cognition. The illusion of time in sleep. The paradox of unconscious awareness. The experience of time during sleep presents a fascinating paradox that challenges our understanding of consciousness, perception, and the nature of time itself. When we sleep, our conscious awareness is largely suspended, yet we often wake up with a sense that time has passed, sometimes too quickly, sometimes too slowly. This phenomenon raises profound questions about how the mind processes time in the absence of conscious awareness, and how the unconscious mind constructs our perception of temporal flow. To explore this paradox, we must delve into the nature of sleep, the mechanisms of time perception, and the interplay between conscious and unconscious processes. The nature of sleep and consciousness. Sleep is a complex physiological state characterized by reduced sensory awareness, altered brain activity, and a temporary suspension of voluntary actions. It is divided into several stages, including rapid eye movement, REM, sleep, and non-REM sleep, each associated with distinct patterns of brain activity and cognitive processes. During sleep, the conscious mind, the part of us that is aware of our thoughts, surroundings, and experiences, is largely inactive. However, the unconscious mind remains active, processing information, consolidating memories, and regulating bodily functions. The suspension of conscious awareness during sleep creates a unique environment for studying the relationship between consciousness and time perception. In waking life, our sense of time is closely tied to our conscious experiences. We perceive time as flowing continuously, marked by events, thoughts, and sensory inputs. But during sleep, this flow is disrupted, and our perception of time becomes distorted. This raises the question, how does the unconscious mind perceive time, and why does it often feel so different from our waking experience? The illusion of time in dreams. One of the most striking examples of the illusion of time in sleep occurs during dreams. Dreams are vivid, often surreal experiences that occur primarily during REM sleep. Despite their intensity, dreams are typically disconnected from external stimuli and the passage of real-world time. Yet, within the dream state, time often feels as real and continuous as it does in waking life. A dream that lasts only a few minutes in real time can feel like hours or even days to the dreamer. This distortion of time in dreams highlights the brain's ability to construct a subjective sense of time independently of external cues. During dreams, the brain generates its own narrative, complete with events, emotions, and a sense of temporal progression. This narrative is not constrained by the linear passage of time in the external world, allowing for experiences that feel much longer or shorter than they actually are. The illusion of time in dreams underscores the role of the unconscious mind in shaping our perception of reality, even in the absence of conscious awareness. The role of memory in time perception. Memory plays a crucial role in our perception of time, both during wakefulness and sleep. In waking life, we rely on memory to create a sense of continuity and coherence in our experiences. We remember past events, anticipate future ones, and use these memories to construct a timeline of our lives. During sleep, however, the relationship between memory and time perception becomes more complex. One of the primary functions of sleep is memory consolidation, the process by which the brain stabilizes and organizes memories acquired during wakefulness. This process involves the transfer of information from short-term to long-term memory, as well as the integration of new memories with existing ones. During this process, the brain may reconstruct and reorganize memories in ways that distort our sense of time. For example, a dream that incorporates fragments of recent experiences may feel longer or more detailed than it actually is, as the brain weaves together disparate elements into a coherent narrative. The role of memory in time perception during sleep is further complicated by the fact that not all memories are retained. Many dreams are forgotten upon waking, leaving only fragments or a vague sense of their content. This selective retention of memories can contribute to the illusion of time in sleep, as the brain fills in gaps and creates a sense of continuity based on incomplete information. The interplay between memory and time perception during sleep highlights the brain's ability to construct a subjective reality that may differ significantly from objective reality. The neuroscience of time perception in sleep. Advances in neuroscience have provided new insights into the mechanisms underlying time perception during sleep. Research using techniques such as electroencephalography, EEG, and functional magnetic resonance imaging, fMRI, has shown that the brain's activity during sleep is highly dynamic, with different stages of sleep associated with distinct patterns of neural activity. These patterns may influence how the brain processes time in the absence of conscious awareness. One area of research that has shed light on the illusion of time in sleep is the study of the default mode network, DMN. The DMN is a network of brain regions that is active during rest and self-referential thinking, including the medial prefrontal cortex, posterior cingulate cortex, and angular gyrus. During sleep, the DMN remains active, particularly during REM sleep, when dreaming is most common. This suggests that the brain continues to engage in self-referential processing and narrative construction during sleep, which may contribute to the subjective experience of time. Another area of research that has contributed to our understanding of time perception during sleep is the study of circadian rhythms. Circadian rhythms are internal biological clocks that regulate the timing of physiological processes, including sleep-wake cycles. These rhythms are influenced by external cues, such as light and temperature, but they also operate independently of conscious awareness. During sleep, the brain's internal clock continues to track the passage of time, even though we are not consciously aware of it. This may explain why we often wake up feeling as though a certain amount of time has passed, even if we have no memory of the intervening period. The paradox of unconscious awareness. The illusion of time in sleep highlights the paradox of unconscious awareness, the idea that we can be aware of something without being consciously aware of it. During sleep, the brain continues to process information, regulate bodily functions, and generate experiences, all without the involvement of conscious awareness. This raises the question, how can the brain be aware of time without the conscious mind being active? One possible explanation is that the brain's perception of time during sleep is mediated by unconscious processes that operate independently of conscious awareness. These processes may include the regulation of circadian rhythms, the consolidation of memories, and the generation of dreams. While these processes do not involve conscious thought, they nevertheless contribute to our subjective experience of time. This suggests that the brain is capable of constructing a sense of temporal flow even in the absence of conscious awareness. Another possible explanation is that the illusion of time in sleep is a byproduct of the brain's attempt to create a coherent narrative. The illusion of time in sleep, the dream world paradox. The experience of time within dreams presents one of the most intriguing paradoxes of human consciousness. While asleep, we inhabit a world where seconds can stretch into hours, where past and future collapse into a single moment, and where the very fabric of temporal reality bends to the whims of the dreaming mind. This phenomenon, where time becomes elastic, discontinuous, and often entirely illogical, challenges our fundamental assumptions about perception, memory, and the nature of consciousness itself. How can a brain that is disconnected from external sensory input generate such vivid, temporally complex experiences? Why do dreams sometimes feel like they span years, only for us to wake and realize mere minutes have passed? And what does this temporal distortion reveal about the unconscious mind's relationship with time? The subjective nature of dream time. In waking life, our perception of time is governed by external cues, clocks, the movement of the sun, the rhythm of daily routines, as well as internal cognitive processes such as attention and memory. But in dreams, these anchors dissolve. The brain, untethered from sensory reality, constructs its own version of time, one that follows no consistent rules. A dreamer might experience an entire lifetime in a single night's sleep or relive a traumatic moment in what feels like slow motion, only to awaken and find that the entire episode lasted mere seconds. This elasticity of dream time suggests that the brain does not rely on objective, external markers to generate a sense of duration. Instead, it fabricates time based on narrative coherence, emotional intensity, and memory reconstruction. A dream that feels long and elaborate may not actually contain more events than a brief one. Rather, the brain fills in gaps, compresses or expands moments, and creates the illusion of continuity where none objectively exists. This is why some dreams feel like epic sagas upon waking. Yet when recounted, their actual content could fit into a few sentences. Neurological mechanisms behind dream time. Neuroscientific research offers some clues about how the brain manipulates time during sleep. Studies using electroencephalography, EEG, and functional MRI, fMRI, reveal that during REM sleep, the phase most associated with vivid dreaming, the brain's prefrontal cortex, responsible for logical reasoning and time perception, is significantly less active. Meanwhile, the limbic system, which governs emotions, and the associative cortices, which construct narratives, are highly engaged. This shift in neural activity may explain why dream time feels so fluid. Without the prefrontal cortex imposing a rigid structure of cause and effect, the mind is free to warp, stretch, and compress time at will. Additionally, the brain's internal clock, governed by the suprachiasmatic nucleus and other timekeeping structures, continues to function during sleep, but its signals are interpreted differently. In the absence of external sensory input, the brain may rely on its own internally generated rhythms, leading to distortions in perceived duration. For example, a dream sequence involving a high-stakes chase might trigger accelerated neural firing, making milliseconds feel like minutes, while a dream of floating in an endless void might slow down perceived time due to reduced sensory stimulation. Memory and the reconstruction of dream time. One of the most puzzling aspects of dream time is how it interacts with memory. Upon waking, we often struggle to recall whether a dream event lasted seconds or hours. This is because dreams are not stored in memory the same way waking experiences are. Instead of being recorded as a continuous, time-stamped sequence, dreams are fragmented, reassembled upon waking, and heavily influenced by emotional salience. This reconstruction process means that our sense of time in dreams is often retroactive, a creation of the waking mind trying to make sense of disordered, emotionally charged fragments. A dream that felt long might simply be one in which many intense or unusual events occurred, tricking the brain into assuming more time must have passed. Conversely, a dream that felt instantaneous might have lacked distinct events, making it seem as though no time had elapsed at all. Interestingly, some studies suggest that the brain may timestamp certain dream events based on real-world stimuli. For example, if a sleeper hears an alarm clock ringing faintly in the background, the dreaming mind might incorporate it into the dream narrative, stretching the sound out over what feels like minutes. This demonstrates how the unconscious mind can take a fleeting external cue and expand it into a seemingly prolonged internal experience. The paradox of simultaneity in dreams. Perhaps the most baffling aspect of dream time is the phenomenon of simultaneity, the experience of multiple events happening at once or in impossible sequences. In dreams, we might witness our own birth and death in the same moment, or find ourselves simultaneously in two places at once. These experiences defy the linear cause and effect structure of waking time, suggesting that the dreaming brain operates outside conventional temporal logic. Some neuroscientists theorize that this occurs because the brain's usual time-binding mechanisms, those that stitch together sensory input into a coherent timeline, are weakened during sleep. Without these constraints, memories, fears, and fantasies can collide in impossible configurations, creating a timeless, fluid dreamscape. This might also explain why déjà vu is so common in dreams. The brain is constantly generating and recombining fragments of memory, creating the illusion that we have already experienced something that is, in fact, being constructed in real time. The role of emotion in distorting dream time. Emotion plays a crucial role in shaping our perception of time, both awake and asleep. In waking life, frightening or exhilarating moments seem to slow down, while monotonous periods fly by. The same principle applies to dreams, but with even greater intensity. A nightmare, for instance, might feel like it stretches on endlessly because the brain is flooded with stress hormones, heightening the sense of duration. Conversely, a pleasant or serene dream might feel fleeting, as the mind glides effortlessly through it without resistance. This emotional modulation of time suggests that the unconscious mind prioritizes experiences based on their effective weight. A traumatic dream event might be expanded in subjective time as the brain attempts to process its significance, while trivial events are compressed or forgotten entirely. This could also explain why some people report lifelong dreams in which they live entire alternate lives. The emotional investment in the dream narrative makes time feel expansive and real. Time loops and precognitive dreams. Another strange temporal phenomenon in dreams is the experience of time loops, dreams in which the same event repeats endlessly, or in which the dreamer feels trapped in a cycle with no escape. These dreams may reflect the brain's struggle to resolve unresolved anxieties, replaying them in an attempt to find a solution. Alternatively, They could be a byproduct of disrupted memory encoding during sleep, causing the same fragments to resurface repeatedly. Similarly, so-called precognitive dreams, where the dreamer seemingly foresees future events, may actually be a trick of memory and coincidence. The illusion of time in sleep, the sleep-wake reality divide. The human experience of time undergoes a profound transformation when crossing the threshold between wakefulness and sleep. This transition creates a striking cognitive divide, one where the steady, measurable progression of waking time gives way to the elastic, often incomprehensible temporality of the dreaming mind. The sleep-wake reality divide presents a fundamental paradox. How can the same brain perceive time so differently across these two states? What mechanisms allow us to completely lose track of hours during deep sleep, yet experience elaborate dream sagas in mere minutes of REM sleep? And what does this temporal discontinuity reveal about the nature of consciousness itself? The neurological switch, how the brain transitions between temporal modes. When we fall asleep, our brain doesn't simply power down. It undergoes a complex reorganization of neural activity that fundamentally alters our perception of time. The suprachiasmatic nucleus, the brain's master circadian clock, continues its timekeeping functions during sleep, but its relationship with conscious perception changes dramatically. As we descend through the stages of non-REM sleep, the prefrontal cortex, the region responsible for logical sequencing and time estimation, becomes increasingly inactive. Meanwhile, the limbic system and sensory processing areas remain highly active, creating a state where emotional and sensory experiences continue, but without the organizing framework of linear time. This neurological shift explains why deep sleep often feels instantaneous. Without the prefrontal cortex's time-tracking mechanisms, the brain loses its ability to gauge duration accurately. The 4-hour stretch of deep dreamless sleep that passes in what feels like a blink demonstrates how profoundly our sense of time depends on specific cortical activity. Conversely, during REM sleep when dreaming occurs, the brain enters a different temporal mode, one where time becomes malleable and subjective rather than fixed and measurable. The memory gap, why we lose track of time during sleep. The sleep-wake divide in time perception is closely tied to how memories form during different sleep stages. During deep sleep, the hippocampus, critical for memory formation, becomes less active, creating periods of amnesia where time seems to disappear entirely. This explains why we typically can't account for large portions of the night's passage. The brain isn't creating the kind of time-stamped memories that allow us to reconstruct duration upon waking. However, during REM sleep, the hippocampus shows bursts of activity, allowing for the creation of dream memories. But these memories form differently than waking memories. Without external sensory input to anchor them in real time, dream memories exist in a kind of temporal vacuum where the brain's internal sense of duration takes precedence over objective measurement. This is why a 5-minute dream can contain what feels like hours of content. The brain compresses narrative time without the constraints of physical reality. The time warp of sleep inertia. The transition between sleep and wakefulness contains its own temporal distortion known as sleep inertia, that groggy, disoriented period upon waking where time perception remains altered. During this transition state, which can last for minutes to over an hour, the brain struggles to reinstate normal time perception. The prefrontal cortex, sluggish from sleep, hasn't yet regained full time-keeping functionality, leading to characteristic temporal confusion. Sleep inertia demonstrates that time perception isn't an all-or-nothing phenomenon, but rather exists on a spectrum that shifts gradually between sleep and wake states. Studies show that during this transition, people consistently misjudge time intervals, either overestimating or underestimating durations, depending on sleep stage at awakening. This suggests that our sense of time doesn't switch abruptly between sleep and wake modes, but rather undergoes a gradual recalibration. The paradox of hypnagogic and hypnopompic states. The twilight zones between sleep and wakefulness, the hypnagogic state when falling asleep and the hypnopompic state when waking, offer particularly striking examples of temporal distortion. In these semi-lucid states, time can appear to stretch, compress, or fragment in ways that defy waking logic. Minutes might feel like hours, or complex dream narratives might unfold in what objectively amounts to seconds. These transitional states reveal that time perception exists on a continuum between full consciousness and deep sleep. The brain in these states appears to sample both modes of temporal processing, maintaining some connection to external time while beginning to employ the more fluid temporal rules of the dreaming mind. This creates unique experiences where, for instance, a person might hear an actual alarm clock ringing in their bedroom while simultaneously experiencing a lengthy dream sequence that incorporates the sound. The discontinuity of sleep cycle time. Modern sleep research has revealed that we don't experience sleep as one continuous, uniform state, but rather as a series of distinct cycles, each with its own temporal characteristics. A typical night's sleep consists of 4 to 6 cycles, each lasting about 90 minutes and containing progressively longer periods of REM sleep. This cyclical structure creates a fragmented experience of time that contrasts sharply with the continuous flow of waking consciousness. The time between these cycles, brief moments of near waking that typically go unremembered, represent another form of temporal discontinuity. While we subjectively experience sleep as one unbroken period, unless we wake fully, in reality it's a series of discrete episodes with gaps our conscious mind stitches together. This helps explain why people often underestimate how long they've slept. The brain doesn't account for these between-cycle pauses when reconstructing sleep duration upon waking. The impact of sleep deprivation on time perception. The relationship between sleep and time perception becomes particularly evident when examining sleep deprivation. Studies consistently show that sleep-deprived individuals have significant difficulty accurately estimating time intervals. This impairment occurs because the sleep-deprived brain struggles to maintain normal timekeeping functions in the prefrontal cortex, while simultaneously dealing with increased activity in emotion processing regions. This neurological state creates a kind of hybrid time perception resembling aspects of both waking and dreaming consciousness. Sleep-deprived individuals often report experiences where time seems to jump, gaps in awareness similar to the time loss of deep sleep intruding into wakefulness. This demonstrates how closely normal time perception depends on adequate sleep and how blurred the sleep-wake divide can become under extreme conditions. The evolutionary purpose of altered time perception in sleep. From an evolutionary perspective, the dramatic shift in time perception during sleep likely serves important adaptive functions. The time collapse of deep sleep may allow for more efficient biological restoration by creating a psychological experience of shortened, what feels like a brief respite, could actually be hours of physical recovery. Meanwhile, the expanded time perception in dreams might facilitate memory consolidation and emotional processing by allowing the brain to rehearse scenarios in what feels like real time. The paradox of letting go, when release becomes the path to control. The human experience is filled with a fundamental contradiction that permeates our psychological, emotional, and even physical lives. The paradox of letting go. This phenomenon reveals that our most strenuous efforts to maintain control often become the very obstacles preventing us from achieving what we desire, while surrender frequently proves the most effective path to mastery. The athlete who thinks too hard about their form disrupts their natural rhythm. The insomniac's desperate attempts to fall asleep only fuel their wakefulness. The individual clinging tightly to a relationship watches it slip through their fingers like sand. These examples point to a profound truth about human psychology, that sometimes the direct pursuit of a goal creates resistance to its achievement, while releasing our grip may paradoxically bring us closer to what we seek. The psychological mechanisms of a letting go paradox. At the core of this paradox lies a complex interplay between our conscious intentions and automatic processes. Cognitive science reveals that many of our most skilled behaviors, from speaking to walking to playing musical instruments, operate most efficiently when governed by unconscious, automated systems. When we bring excessive conscious control to these processes, we often disrupt their natural flow. This explains why the golfer who analyzes every muscle movement during their swing typically performs worse than when they trust their trained instincts. The prefrontal cortex, responsible for deliberate control, can actually interfere with the well-honed patterns developed in other brain regions. This interference extends beyond physical skills into emotional regulation. Studies in emotional processing demonstrate that attempts to suppress unwanted thoughts or feelings frequently lead to their rebound effect. What we resist persists. The classic white bear experiment, where participants told not to think of a white bear found it impossible to keep the image from their minds, illustrates this psychological irony. Our mental processes seem designed such that the very act of trying to eliminate a thought or emotion gives it energy and staying power, while acceptance and non-resistance allow it to pass naturally. The role of attachment in perpetuating struggle. Attachment theory, while originally developed to explain child-caregiver bonds, offers valuable insights into this paradox across human experience. Our attachments to outcomes, to identities, to possessions, to other people, create psychological tension that often undermines our aims. The musician who becomes overly attached to perfect performance may experience stage fright that mars their playing. The businessperson fixated on a particular deal may negotiate poorly out of desperation. In each case, the strength of attachment creates anxiety and rigidity that prevent the fluid adaptation needed for success. Neurobiological research suggests this occurs because strong attachments activate threat response systems in the brain. When something we're attached to feels endangered, the amygdala triggers fight or flight responses that actually impair the flexible cognition and emotional regulation needed to navigate challenges effectively. Thus, the more desperately we cling, the more we activate neural systems that make skillful release impossible. The physiology of release. The paradox manifests physically in our body's stress response systems. Chronic tension, whether physical muscle tension or psychological stress, creates self-perpetuating cycles where the effort to relax becomes another source of strain. The clenched jaw trying to unclench, the insomniac striving for sleep, the anxious person laboring to calm down, all exemplify how voluntary relaxation efforts can backfire. Polyvagal theory in neuroscience explains this through the autonomic nervous system structure. Our bodies have evolved sophisticated automatic systems for calming and activation that often function best when we stop trying to control them directly. The sigh of relief that comes when we finally give up struggling, the sudden sleep that arrives when we stop trying to sleep, all point to physiological systems that operate optimally outside direct volitional control. Cognitive load and the wisdom of unthinking. The concept of cognitive load provides another lens on this paradox. When our working memory becomes overloaded with conscious attempts to control processes better left automatic, performance suffers. This explains why overthinking disrupts everything from athletic performance to creative inspiration to social interactions. The mental space occupied by conscious control leaves less capacity for the intuitive, pattern recognition capabilities of our unconscious processing systems. Flow state research reinforces this understanding. Those moments of peak performance and experience characterized by complete absorption typically occur when we release conscious control and allow action to unfold spontaneously. The artist lost in their work, the athlete in the zone, the speaker carried by their words, all describe states where letting go of deliberate control enables higher levels of achievement than conscious effort could produce. The developmental perspective. Human development itself follows this paradoxical trajectory. Psychological growth often requires releasing previous ways of being to make space for new capacities. The toddler must release their grip on furniture to walk freely. The adolescent must let go of childhood dependencies to mature. The adult must release fixed self-concepts to continue growing. At each stage, development demands a surrender of what came before to allow what comes next. This mirrors the biological concept of apoptosis, programmed cell death that enables growth and renewal. Just as our bodies require the death of certain cells to develop properly, our psyches require the release of outmoded patterns, beliefs, and identities to evolve. The paradox appears in our resistance to these necessary releases, how we often cling to limiting patterns, even when they constrain our potential. The social dimension. Interpersonal relationships provide perhaps the most poignant examples of this paradox. The more we try to control another's feelings or behaviors, the more we often push them away. The parent who grips too tightly may inspire rebellion. The partner who demands love may smother it. The leader who micromanages may stifle initiative. In each case, the attempt to control creates resistance, while allowing autonomy frequently inspires willing cooperation. Social psychology studies on reactance theory confirm this phenomenon. When people perceive their freedom is threatened, they often react by asserting their autonomy in the opposite direction. Thus the paradox: the more we try to force connection or compliance, the more we may undermine it, while giving space often creates the conditions for the creative process. Creativity thrives on this paradox. The writer who strains for inspiration often meets only frustration, while ideas flow when they stop trying. The incubation stage of creativity, where solutions emerge after periods of not consciously working on a problem, demonstrates how releasing direct effort allows unconscious processing to produce novel connections. History brims with examples of scientific breakthroughs and artistic inspirations that came not through force of will, but in moments of release and surrender. The paradox of sleep and creativity, when mental rest becomes the source of invention. At first glance, sleep appears to be the antithesis of creative work, a state of unconsciousness where the mind disengages from active problem-solving and deliberate thought. Yet some of humanity's most significant creative breakthroughs have emerged from this very state of apparent passivity. Dmitri Mendeleev reportedly envisioned the periodic table in a dream. Mary Shelley conceived Frankenstein during a sleepless night filled with vivid waking dreams. Paul McCartney awoke with a melody for Yesterday fully formed in his mind. These examples point to a profound paradox. The brain's most creative insights often arise not from focused effort, but from the cognitive freedom of sleep and its twilight states. The neuroscience of sleep-related creativity. Modern neuroscience has begun to unravel this paradox by examining how different sleep stages contribute to creative thinking. During REM sleep, the phase most associated with vivid dreaming, the brain exhibits a unique pattern of activity that appears ideally suited for creative synthesis. The prefrontal cortex, responsible for logical constraints and self-censorship, becomes less active, while the limbic system, associated with emotions and sensory processing areas, show increased activation. This neurological configuration creates a mental environment where unconventional associations can form freely, unimpeded by the critical filters that dominate waking thought. Simultaneously, the brain engages in widespread neural connectivity during REM sleep, creating links between disparate memory networks that might remain separate during wakefulness. Functional MRI studies reveal that the sleeping brain forms connections between distantly related concepts at 3 times the rate observed in waking states. This hyperassociative state may explain why dreams often feature bizarre juxtapositions, and why these same mechanisms can produce genuinely innovative insights when applied to waking problems. The non-REM stages of sleep, particularly slow-wave sleep, contribute differently to the creative process. During these deeper sleep phases, the brain engages in memory consolidation, sorting, strengthening, and integrating the day's experiences. This process appears crucial for incubation, where problems left unresolved during waking hours find solutions after a period of sleep. Research demonstrates that people who sleep after being exposed to complex problems are significantly more likely to find creative solutions than those who remain awake for equivalent periods. The sleeping brain continues working on problems in ways the conscious mind cannot access directly, often arriving at solutions that feel spontaneously revealed upon waking. The role of hypnagogic and hypnopompic states. The transitional states surrounding sleep, hypnagogia when falling asleep and hypnopompia when waking, appear particularly fertile for creative insights. These liminal states feature a unique blend of waking cognition and dreamlike imagery, creating what some researchers call the creativity sweet spot. Thomas Edison famously exploited this phenomenon by napping with steel balls in his hands. As he drifted off, the balls would fall and wake him at the optimal moment for capturing creative ideas. Neurochemically, these transitional states feature a mix of neurotransmitters that may enhance creative thinking. Dopamine levels rise during the transition to sleep, potentially increasing cognitive flexibility, while residual melatonin may reduce inhibitory thought patterns. At the same time, the brain begins accessing long-term memory networks while still maintaining some conscious awareness, allowing for the recognition and capture of novel associations that might otherwise remain unconscious. Studies of creative professionals reveal that many deliberately cultivate these states for problem solving. Architects, writers, and scientists report receiving valuable insights during these drowsy periods when logical constraints weaken but conscious direction remains possible. The paradoxical combination of reduced executive control and maintained awareness creates conditions where truly original ideas can surface. Sleep deprivation's double-edged sword. The relationship between sleep and creativity becomes even more paradoxical when examining sleep deprivation. While chronic sleep loss undoubtedly impairs cognitive function, short-term sleep deprivation appears to have a complex relationship with creative thinking. Some studies suggest that moderate sleep deprivation can temporarily increase divergent thinking, the ability to generate multiple unconventional solutions, possibly due to decreased prefrontal cortex activity mimicking aspects of the REM sleep state. However, this effect follows an inverted U-curve. The creative boost peaks after about 24 hours of wakefulness before declining sharply as impairment overwhelms any benefits. Moreover, the type of creativity affected appears specific. Sleep-deprived individuals may generate more ideas, but the quality and appropriateness of those ideas suffers. This explains why many artists report productive all-nighters, while also recognizing the unsustainable nature of such practices. The creative benefits of sleep deprivation seem to stem from the brain's compensatory mechanisms as it fights to maintain function, not from deprivation itself being inherently beneficial. The incubation effect, how problems solve themselves during sleep. The phenomenon of waking with a solution to a previously intractable problem, what we commonly call sleeping on it, has been validated by numerous studies. In one classic experiment, participants given a complex number reduction task were 3 times more likely to discover the hidden rule after sleeping compared to those who remained awake for an equivalent period. This incubation effect appears strongest when individuals engage deeply with a problem before sleeping, then allow their minds to rest. Neuroscientists propose several mechanisms for this effect. During sleep, the brain replays waking experiences at accelerated speeds, allowing for novel pattern recognition. The hippocampus reactivates recently formed memories and integrates them with existing knowledge networks, often making connections that conscious, linear thinking misses. Additionally, sleep appears to facilitate the abstraction of general rules from specific examples, a process crucial for creative insight. This explains why many creative breakthroughs follow periods of immersion in a problem followed by mental rest. The composer Igor Stravinsky reported hearing musical solutions in his dreams after intense work sessions. The chemist August Kekulé discovered the ring structure of benzene after dreaming of a snake biting its tail. In each case, conscious effort provided the raw materials that sleep subsequently recombined in innovative ways. The role of dreaming in creative problem-solving. Dreams themselves serve as a kind of nocturnal workshop for the creative mind. Unlike waking thought, which generally follows logical, linear paths, dream cognition operates through loose associations, emotional salience, and visual symbolism. This alternative mode of thinking allows problems to be approached from entirely new angles. Sleep and the creative personality. Certain personality traits associated with creativity also correlate with distinctive sleep patterns. Openness to experience, one of the strongest predictors of creative achievement, shows consistent relationships with dream recall frequency and vividness. People scoring high in openness tend to have more complex, emotionally intense dreams and often find creative inspiration in them. Moreover, the circadian rhythms of creative individuals often differ from the general population. Many self-report as night owls, with their peak creative periods occurring in late evening or nighttime hours. This may reflect an evolutionary advantage. In ancestral environments, having group members with different activity patterns would have provided continuous coverage against threats. In modern contexts, this biological timing places creative individuals in wakeful states during the very periods when their brains are most likely to enter creative, dreamlike modes of thought. Practical applications. Harnessing sleep for creativity. Understanding this paradox leads to practical techniques for enhancing creativity through sleep management. The targeted dream incubation method, for instance, involves focusing intensely on a creative problem before sleep, while priming the mind to maintain awareness of dream content. Studies show this can increase solution rates for complex problems. Another approach involves strategically timing sleep to maximize creative insights. Short naps containing REM sleep have been shown to boost performance on creative tasks more effectively than longer naps or no nap at all. Many creative professionals develop personal rituals for capturing hypnagogic insights, from keeping dream journals to using voice recorders upon waking. Sleep scheduling can also optimize creative output, aligning work sessions with natural circadian rhythms, allowing for incubation periods between intensive work and sleep, and recognizing individual differences in creative timing all contribute to more productive creative workflows. The key lies in recognizing sleep not as time lost to productivity, but as an active participant in the creative process. The limits and liabilities. While the creative benefits of sleep are well established, misconceptions abound. Romanticizing sleep deprivation as a creative tool can lead to serious health consequences. The creative boost from short-term sleep loss must be weighed against the well-documented cognitive impairments that follow. Similarly, while some creative individuals may thrive on unconventional sleep schedules, chronic circadian disruption carries significant risks. Moreover, not all creative domains benefit equally from sleep-related processes. Fields requiring extensive logical analysis or precise execution may benefit less from the loose associations of sleep states than those valuing novel connections or abstract thinking. Understanding these boundaries helps apply sleep creativity insights effectively without overgeneralizing. Future directions in research. Emerging technologies are opening new avenues for studying this paradox. Advanced EEG systems combined with machine learning now allow researchers to detect specific sleep stages with unprecedented precision, enabling more nuanced studies of how different sleep phases contribute to creative thinking. Brain stimulation techniques like transcranial alternating current stimulation show promise for enhancing sleep-related creativity by modulating specific brainwave patterns during sleep. Sleep tracking wearables and smart technology may soon allow individuals to optimize their sleep for creative output, identifying personal patterns in sleep architecture that correlate with creative breakthroughs. As these tools develop, we may gain even deeper understanding of how the sleeping brain becomes such a powerful creative engine.